Hello there guys, welcome back to another epic inexorable maths video. We're doing another video on improper integration today. Now the integral right here may look innocent, but it is guilty as charged because even though there is no infinity in either of the limits, we do still have an issue, and that is this zero down here. So have a think about it. Why is the fact that zero is one of the limits here an issue? Well, when we divide by 0, 1 divided by 0 squared is basically infinity, or at least it's undefined. So this is going to be an improper integral. So the way that I'll explain this one is, as always, I'll draw a little graph. And again, I only really care about the positive part of the graph. So I'm not going to draw the entire thing, I'm just going to draw the part of it that is to the right of the y-axis. And this is what the graph of y equals 1 over x squared looks like. Y equals 1 over x squared. Okay, now the area that we want is the area between 0 and 1. Okay, so maybe 1 is about there. And obviously 0 is here, it's just the y-axis. But as you can see, we have an asymptote that goes up to infinity. So we've seen in previous videos, and by the way, I'll leave a link in the description to the improper integration playlist if you've not seen those videos. But we've seen in previous videos that the area from 1 to infinity of this function is actually just the number 1, even though we go to infinity. Will it be the case then that the area to the left of the number 1 will be the same thing or even finite at all? Well, we're actually going to find out that maybe this area, the area to the left of the number 1, between 0 and 1, maybe this area is actually going to be infinite. Well, let's see, let's work it out. How should we do this then? Well, we're going to use a very similar idea to how we did the ones in the previous videos where we let t go to infinity, but this time we're going to let t go to 0. So I'm going to think of t as a number between 1 and 0. Maybe t is about here, for example. And what I'd like to do is come up with some sort of algebraic expression in terms of t for this area here. And I'm going to let t get closer and closer to 0. So t is going to go to the left. It's going to get closer and closer to 0. And we're going to see what happens to the area. So let's do that right here. So that integral is equal to the limit, as this time t is going to 0, of the integral from t to 1. Hopefully that makes sense. T is on the bottom because it's the lower limit. And 1 over x squared, I'm just going to rewrite it. I'm going to rewrite it as the exact same thing. I'm just going to write it as x to the minus 2 just because that's a bit easier to actually integrate. Okay. Then I'm going to actually do the integral. So x to the minus 2 integrates to minus x to the minus 1. Okay. And the limits again are t and 1. Okay, then we can just plug everything in. So we have the limit again as t approaches 0. And what do we have here? Well, we plug in 1 first this time. So we have minus 1 to the power of minus 1, like this. Subtract minus t to the minus 1. Okay, so let's just do a little bit of simplifying before we actually try to do the limit stuff. So we have the limit as t goes to 0 of, well, 1 to the minus 1 is just 1, and minus that is minus 1. So this is minus 1. And then we have a plus, because minus minus, t to the minus 1. T to the minus 1 is 1 over t. So we have a plus 1 over t, like that. Okay. Now guys, what this here is an expression for the area that I have drawn if t is a number between 0 and 1. But now we're going to let t actually approach 0. And what happens? Well, as t approaches 0, what we have is this 1 over t. And what do you think that is going to approach as t approaches 0, 1 over t? That's going to approach infinity, of course, because we're doing 1 divided by a bigger and bigger and bigger number. That's getting bigger and bigger and bigger. Let me rephrase that. we're doing 1 divided by a smaller and smaller and smaller number, which becomes a bigger and bigger and bigger number, okay? 1 divided by a number that's going to 0 is going to get very big, and that's why it's infinity. So what we have is that this integral is like -1 plus infinity, and that's not too good. So this means that actually this area from 1 to 0, or I should say from 0 to 1, is actually infinite, so it diverges. So this is a divergent integral. Diverges. It does not equal a finite value, which maybe that is surprising, because again, we know on this function, the area from 1 to infinity actually converges to the number 1. But from 0 to 1, it diverges. But that's just the way the biscuit breaks, guys. Sometimes that happens. So yeah, that's an example of how we deal with an improper integral where actually there is no infinity here. We just have a different type of problem. And as always, there will be plenty more videos on this topic to come, so stay tuned. Let me know if you need anything at all, guys. If you want me to make any videos, I will do it. Okay, and I'll see you in the next video. Cheers.